right, welcome everyone. Thank you for joining us in our the start of the last track for the session, which is manageability. We have 3 great presentations in a weird order, but we have them. So I'll kick us off with a bit of an overview here. I'm Rochelle Alvers. I run the storage management community, as well as I have chaired the Swordfish Twig for 10 years. Basically helped kick off the whole thing, and somehow got stuck in charge of it the whole time. We will go over a handful of stuff. This is the abstract. It was what was printed online that nobody read. Basically what I would do is just give a really quick overview of what Redfish is, how it relates to Swordfish. I'm going to leave the discussion on what some of the new features are in Redfish that pertain to us to our next presenter, which is Jeff. I may start talking about something and say, nope, Jeff's going to talk about that and cover it a little bit later. And then we'll talk about what kind of functionality we've been adding in the past year, kind of give you a sense of where we're seeing demand for feature enhancements, as well as a little bit of an overview on a completely new area we've started working on as well. And I'll just leave a little teaser there, even though it's on the slide already. We'll get to that here shortly. There's me. So what are Redfish and Swordfish? Are they radically different? Are they, do we just rename all of the Redfish stuff? Are they separate? So really what Redfish is manageability. If you've been under a rock somewhere and you haven't heard of Redfish already, it's server management, it's network management, it's all the base infrastructure. So, many moons ago, we basically said, well, we need to expand that rather than creating a completely separate standard for storage management. And SNIA became the home of that because we're the storage experts. So we partner very, very closely with the Redfish organization. We have joint meetings set up every 2 weeks. It is one of the tightest partnerships I've seen in the standards community. So Redfish covers, again, that server side. It's REST-based. We actually have multiple different types of schema that get generated, and we actually leave that all up to the Redfish side to drive. And we just focus on the storage-related functionality here. So we can have JSON schema. We have YAML schema. There's another one coming along that I haven't been paying attention to. Jeff may mention that one. So, but there's a lot of flexibility in there, and all of the basics in Redfish you can use in Swordfish. And I'll show some examples here in a little bit. Show some details here of where Swordfish actually sits, and then a couple of different applications just as a quick primer on the system. As we jump in here, we'll start very high level, right? If I were to build, you can do some storage in base Redfish. These are simple configurations. Think of this as I don't need a pool. And then you're in the right ballpark. So you can attach a drive, you can go off and model everything on the Redfish side. For local attached storage for SAS devices, SAS and SATA, that's exactly there's implementations start there. But when you start getting above a certain number of drives, then that breaks down a little bit because you want to add pools, and so that's really the break point where we start looking at moving to the Swordfish models. So you can see a bunch of different things on here on how Redfish is structured. We have basically a logical view for a component, and this one highlights the logical view of a computer system. And then you have the physical view. Think of anything that might be a FRU in a system, you're going to end up with something in the physical view for that model. So components a lot of components have both logical and physical components, so you'll see, and There is some strategy behind how some of those evolved, but some of them were all just, we're going to do it this way, and somebody proposed it, so they ended up that way. The other piece is manager. This one on the server side is really looking at, these are predominantly BMCs. It's predominantly a BMC, a way to expose all the details and configuration manageability of the BMC itself. On the storage side, we have a little bit broader application. So there's the basics. If we look at it, then where do we extend it? It's even color-coded for your viewing pleasure. We have, you can see, the red ones are really, what we wanted to highlight here is there's a bunch of stuff we don't change. We just use directly. We take all of the services. We use them directly. So, accounts, sessions, all of the basic services, the event service, we don't have any storage specific things there. What we do have are some storage, a few, like on the accounts we're working on, how do we clarify storage administrator, but that rolls down in, and it's just a few additional properties basically. So I'll talk a little bit more about some future work we have going with that in a little bit. Then you can see a couple of areas where we've gone completely purple, right? The purple being the SNIA color, the red being the DMTF color, because it's super small on, up here. But those purple ones are basically, SNIA is the predominant user of those. The ones that are gradiated, some of them DMTF owns, some of them SNIA owns. It's been a little bit arbitrary, but those are ones where we both contribute functionality and have multiple use cases for this. So quite a bit of, hopefully you can see all of the leverage in here. So when we're looking at the standard storage model, you have, instead of where on the previous slide you went into /server, this one you now go, or sorry, /system, this one you now go into /storage. You want to find any storage systems on, whether they're attached behind a server, whether they're standalone, you can always go to Redfish v1/storage and find them. So we go from there down, and this basic model on this screen would be something that would be roughly equivalent to an external array, fairly standalone at this point. We don't have a server on there that we're connecting to or anything. Here's just our server, our storage management. So this goes, we start with a subsystem, and then inside a subsystem, you have pools, you have drives, you have volumes. Those volumes may be replicas. And then there's also additional connectivity, which I don't show here. I'll give an example of in a little bit as well. So if we want to show mapping and masking, if we want to show switch connectivity, and an additional, configuration and connectivity for, iSCSI or fiber channel or whatever, you can do that in the Fabrics model as well. So that just supplements the base. This is the base device model, and then you can add the connectivity in. So one of the things we did was 3-4 years ago, we actually started a 3-way alliance agreement and joint work, but with NVMe, DMTF, and SNIA, and said, how do we map NVMe devices in? So the NVMe guys came in and gave us a giant, here's everything that's way cool and unique about our devices, and I and others worked with them and said, well, that looks like a subsystem, and that looks like a volume, and and how can we map all of your things into the model in a standardized way as possible? And so one of the things we've also done is we've had some documentation that we've built, like the Swordfish NVMe Model Overview and Mapping Guide, that describes all of this and shows you how to map all sorts of different NVMe configurations into Swordfish. So this is not that dissimilar from the last, basically take the last two pictures and merge them together a little bit. So if I have an NVMe drive or device, I'll just say device, mapped to a system, this is more what my model will look like. So I'll have that /systems, I'll have, the computer system itself modeled, and then on that there's a system/storage where you can add a link to the storage device. And then you can also, under /storage, you'll see the objects themselves, or there's this storage device for a storage subsystem. And then under that, you've got pools and volumes and controllers. I didn't highlight the controllers on the last one, but in this case, we reuse controller, and we leverage in some configurations that could be a physical controller, and some cases that could be the NVMe logical controllers. But since they're all controllers, we basically use the same base schema to cover both of them. So then you can see, namespaces on the NVMe side. It's a volume. So we use volume. We've added, we add a bunch of specific properties into volume that are truly NVMe namespace specific things. They're easy to find. It follows the Redfish pattern of here's the technology, and here's all the things that only apply to this technology. So let's see. And you can see that some here, I talked about storage pools earlier. In the NVMe parlance, there's two different ways to think about pools. If you've got some form of array that's doing its pooling, that's actually a separate thing. The NVMe constructs also have endurance groups and sets, and those things just happen to look a lot like pools as well. So we're able to just reuse a whole lot of the components by just kind of identifying your NVMe thing over here is one of these. Your NVMe thing over here is one of these. Okay, so we also then, I talked a little bit ago about using fabrics. One of the things we've done here is looked at how do we deal with access management. So access management has got, a particular model for traditional storage. When you get to NVMe, there's some unique ways to do it, but what we've done is standardize the model across all of them. And for that, we use, under our fabrics model, we use a combination of three objects: the connection, the endpoint, and the zones. And I highlight connection because it'll make more sense when I get to the next slide. But connection is really where you say it's on a traditional array. It might be where we do mapping and masking. NVMe doesn't have that, but we use the same object and just slightly different properties to reflect all of the access management and connectivity, the read-write, a lot of the same kinds of things that you can do there. Then we wanted to add connectivity. So, starting to get past just I have my single device modeled, how are things interconnected? And then we go to the switch endpoint and zone. So instead of the connections, we actually use the same information. A lot of those endpoints, objects can be shared between these two applications. So what we can do with connectivity then is model whatever type of switch it happens to be connected to, and then leverage the endpoint for the connection abstraction, and then of course zones are zones for here. So, and again, so I'll point out the tiny little bit of color coding on this one. You can see the switches one is pure Redfish. We have not at this point needed to do any storage specific switch modeling. So right now we just use the Redfish one. We've had kind of a long-standing question about whether there's going to be a demand at any point to bring fiber channel forward. If we went to model fiber channel switches, we might change that because the fiber channel switch model is far more complex than a lot of the other switches we're dealing with in this infrastructure. But for now, it's just the Redfish one. So you can see, the fabrics are standard Redfish, the switches are standard Redfish, and where we've added enhancements for the storage applications are in this particular piece of it. We've added a lot in endpoint for because a lot of the endpoint abstraction is around the storage interface. Yes, sir.
One point is that when we say endpoints, that could be an initiator, it could be a target. We found the initiator and target look the same, so make it one thing, and inside of it, you've got a field that says it's initiator or a target. Could be fiber channel, could be high could be something else.
Okay, so just for the recording, just to kind of repeat the point, endpoints is itself an abstraction. It can be an initiator or a target. So everything is just kind of wrapped up because the rest of the properties are pretty common. All right. So, yes, sir.
So is there any notion of recursiveness in this graph theory of connectedness?
In the fabric side specifically, or just in general?
I'm thinking more in general. It's like if
Okay.
you've got, a disk volume, then it looks like a disk at some level.
Yep. So the question again for the video is, what recursiveness is built into the model and kind of where is it? So we, yes, the short version is we have built in a lot of abilities to do things like create pools out of pools. So you could take a pool, you could create sub-pools and make a bigger pool. You can create, and then underneath that, you could have that pool be made out of volumes or drives or file systems. And so there's the ability to basically layer and construct based on how you want to aggregate to get your volumes. The higher order objects are volumes, file systems, and object store. And so to get to those, you can actually create those out of pools, but you can also use those as building blocks for pools. So there's a few other spots that have kind of, I'll say, layered capabilities, but that's actually the kind of the biggest area of how you're constructing your system. Okay. So what have we been working on lately? So this is super tiny on my little screen up here, so you guys may be able to see it better than I do. In the last year, so look, right at a year ago, we released 127, and that included some new documentation. We added the interoperability guide. We also added our features registry, which I meant to talk about on one of the previous slides, so I'll get it now. The features registry, we enhanced substantially to make it work on a resource level. What the features registry is it is an enhancement that Swordfish uses to basically advertise what capabilities your system has. And so you can go in and say, I support provisioning, I support replication, I support, and thinking about these from a client perspective, a lot of the functionality we define is mapped into these kinds of things. So I support, base discovery. I support NVMe drive capabilities. And there's profiles that are associated with each of those that say specifically what that means. Some of them are pretty simple, and some of them are like, NVMe drive means you support all of these properties across all of these objects. Provisioning means I can create volumes. So, there's different levels of complexity there, but that's really where the features registry comes in. And so we had a demand to move this to resource level. Instead of just saying, hey, somewhere in this entire environment, I support provisioning. Now you can actually specify where you support provisioning or which portions of the system support replication. Because, as you get into a very large environments, it can vary quite wildly in terms of what features and what functionality is supported on which devices. So this is just, it's a little bit of a shortcut so that a client can come in and say, I know what you support here. And also, here's the specific resources that this works on. We do have test tools, which I'll talk about later, that can actually verify that, all of your claims are correct as well. So additional benefit for the clients, if you can come in and say, yep, SNIA did vendor neutral testing and verified that, what the stuff that I advertise is correct. Okay, so we also added some NVMe functionality. So NVMe is getting a lot of incremental control. One of the things we're seeing from CSPs across the board is really a desire for very granular control of NVMe. So in general case, a lot of DevOps will not get into this, but when you get to the CSPs, they want a lot of detail exposed around the NVMe devices. So you'll see in our list of releases just incremental functionality getting more and more detailed. Last year we added the command and feature lockdown, and we've got some additional enhancements coming to and some related functionality here later this year. I'll talk about that in a future slide. Then we released 128 earlier this year. We made some enhancements to the NVMe over Fabrics white paper. It is the second most downloaded document in the Swordfish. We have the Swordfish bundle, which basically gives you everything, but this paper is where we get the most hits in our documentation set. We've also gone through and clarified the usage, added to file system, file share usage in two places, one of which is in our user's guide. So a better explanation of how to do specific functions, as well as updating mockups for things like an abstract file system. And so here's something where you don't show an abstract file system is where, in our parlance, is really just we're not showing any of the underlying details. All you see is a file system. And then we also have other details where we show if you want to model an entire system with the volumes underneath it that comprise the file systems, we've added all of those in as well. So we provide examples of how to do all of the stuff. So what's coming? I kind of previewed this a little bit. There's a new feature that's been rolling out in NVMe over the last few months. Started earlier this year. It was an update included in the NVMe release that was just announced at FMS 2 weeks ago, 3 weeks ago, however long ago that was. I have no sense of time. So personalities, we're working on how we add these in. And one of the things we do with NVMe and with other devices, which I'll talk about as well, is when we're doing a model, we figure out how to simplify it as much as possible and look at what are the actual command and control people need. Nobody needs to see all of the details that they put in the NVMe spec. I don't think the NVMe spec writers need to see all that detail. So anyway, so personalities, what personalities are is really this collection of settings. And they help determine the NVMe device behavior. And so what we're really adding in is these pre-configured collections. There's a really standard one, like reset to manufacturing defaults. There's ones like basically put it in a secure mode. And so this is the level of control that we're adding, is basically like you have permission to configure it, turn these on, turn these off. So that's, in a nutshell, where personalities are coming.
I can see that being heavily used by hardware manufacturers like HP or Dell might want to set a certain SSD to the HP known specifics, kind of like we used to do with mode pages on hard drives. That we set all the values exactly like we like them, so when the array shifts, we know that those drives will behave a certain way. That differ from the default operation. Yep.
So okay, repeating for the tape. No, not a problem. Chris is just highlighting again that this is likely to be extremely useful and used heavily by the server vendors and the like to pre-configure and reconfigure similar to mode page applications. Okay. Come on, there we go. So we have a bunch of other stuff we're working on. We're targeting our next release, which will be 129, coming in Q4. And the reason I can't be super definite on the time yet because of what's on the next couple of slides. But what we've already added is reservations. So reporting on reservations. So reservations are all done in band. We're not trying to configure them, but we're trying to basically add the ability for implementations to report the current state of the reservations. We've also done a lot of enhancements on our events. So Redfish originally started with a model, with one model for events, and then has pivoted it based on feedback, which is basically folks want to see very specific events rather than the generic events. We started with fairly generic events. And so what we're doing here is basically adding, I'll call them, for this purpose, domain specific, right? So you have a storage, and then you might have storage class. If you have class of service implementation, you might have a storage class of service. If you want mapping and masking, you might have storage mapping and masking. And what that lets people do is actually register to receive the events in the domain they care about. There's another level that implementations can do, which is basically like per resource, but it's pretty heavyweight. And what we've been seeing is folks wanting to register like for everything in a particular category. If you're just talking to a single server, that's much different than if you're talking to an array with 1,000 volumes and you get updates anytime a snapshot happens, which you may want to do, but you need to be able to filter those down. And so we're trying to bring some of those events down and make them manageable. So you do get a very clear volume created, volume deleted, volume created, volume deleted, and the pointers to it. But you can also limit who needs to register to get those events to only people that actually care. You could also only register for errors as opposed to getting all of that spam. And then the third area, we continue to enhance documentation. About at least every other release, we're adding a new document to the set. So one of the things we're adding this time is we've had an error handling guide that kind of walks you through if something fails, use this error for these circumstances, because there's a little ambiguity between in the system to understand all of those. And so what we've added here is also similar guidance for all of the events. So as we're adding all of these new events, we give you examples and how to use them all. All right, so then we get to other future stuff. This is not necessarily all in the 129 timeframe, but these are on our plate, and we have some work going. We're building a storage-specific privilege registry, and I have not yet described what the privilege registry is. Basically, the privilege registry identifies, and a systems consider like a Redfish kind of template for it, and so we'll be building the Swordfish template. When you go to build an implementation, you can customize that to your heart's content, but it basically says for each type of object, who has permissions to do what. So sessions, right? A session, no one can read this, the super details of like somebody's account password or session keys. Only specific users can do that. So it really is allowing us to beef up and add things like a storage administrator, a cloud admin, a cloud user, a storage operator. So we're adding a bunch of roles. We'll add a bunch of roles in addition to that. Again, the Redfish model works really well for a single system, for a single server, but the model there is an admin gets permission to do everything, and we know we have a lot of configurations. We don't want that. We don't want to allow that in a storage world. Folks want to turn that off. So we're giving a standardized option to say, here's your storage admin and what they can do. The whole point behind all of this is that folks don't have to create the entire model from scratch for your own systems. It's just building the storage part, I can tell you it's non-trivial. Okay, the next thing is we're building some tools, and we're doing this in conjunction with the Redfish team. So between the Redfish team, we're going to build a model, build tools that allow you to take the Redfish and the Swordfish and merge them, or take your OEM one and the Redfish and Swordfish ones and merge them, or whichever variant you want, so that you have the ability to basically create these a lot more simply. The third thing, now we start to get interesting. I've been hinting at this one a little bit. I'm really having fun with this one. We spent a lot of time on it this week, even at the Plug Fest. But we're working with the DNA Data Storage Alliance, DDSA, within SNIA to develop how do we build a standardized interface for DNA-based storage devices, and how do we map that into Swordfish? Spoiler alert, it's really a lot like the NVMe thing we just did. So, but I can't talk about the details yet because this is all still SNIA IP, and we will release some information about it soon. Yes, sir.
Isn't there a fourth missing bullet there about our future functionality that we're waiting for the storage AI team to come to us and say, what do we want to add to the model?
Yes, thank you. So you guys have been hearing about storage.ai all week, and as Chris points out, I did not put it on this slide, but the expectation is that Redfish and Swordfish are the basis for managing anything that comes out of the storage.ai infrastructure. So we will, in fact, I think it's even going in the group charter. So we don't expect there to be, completely different APIs coming out, or manageability APIs. So as we move forward with concepts like GPU Direct, the expectation will be that we develop the instrumentation and integrate that up into the Redfish and Swordfish models. Okay, so I put a tiny little primer in here for the DNA side, so that I could talk about, what it is that we're doing. So I'm not going to do this in a ton of detail, but I do want to talk a little bit about what they're working on, right? So they have 5 different areas they're working on. They're roadmaps and white papers. Biosecurity is huge, really cool. We won't talk about that. And then the interoperability and commercialization as folks are moving closer to production. How do we drive common terminology, common interfaces? Where is the standardization pieces? That's a lot of where that comes from. So jumping in a little bit, basics. There are this is an archive system. This is a long-term archive system. So what these are really doing is you take a data object in, and instead of writing it to tape or writing it to flash or writing it to anything else, it gets converted into DNA. And if you're wondering about, boy, that sounds dangerous, what if something horrible comes out of that? That's where the biosecurity piece comes in. But what we're really trying to do is we basically store it in a stable DNA storage, and it can last for 100 years? More than 100 years, yeah. So one of the things that we do in that is so that's kind of the basic model. Here's some of the standardization that we're looking at as I'm checking my time here. So this is really kind of, as we're standardizing, what are the different components in the system? And this is kind of a lot of the first language. I expect this to evolve very quickly over the next few months as we've started doing all of this modeling to get that the DDSA to really push what are the standardized terms. Because I've come up with a few this week or in the last few weeks, and we'll just need to go back and say, do folks generally agree on this? We have a company that is working on productizing a DNA storage appliance that actually sits in large data centers and stores objects. And so as we're moving forward with that, we're both modeling an abstraction of that and a small set of functionality that we expect the DevOps admins in that configuration to actually do a lot of event notification, a lot of fru management, all those kinds of things. And then as we move forward with the technology, we can add more control on the logical side, but the initial implementations don't expose that. So this is kind of where we are. This is basically what we're doing is taking that, modeling these two things under, no surprise, chassis and storage. So we've been able to take those objects and map them to, it's a physical thing. And in fact, there's lots of parts of it that are going to use same terminology as if we were doing tape libraries, right? There's going to be a card library. DNA is stored on little cards. So there'll be a card library. There'll be controllers. There'll be the subcomponents of those cards, which we're still working on names for. I'm calling them containers right now. And all of those, you get the physical model so you can see that fru information. This card, something about this card is bad, flag it, initiate a repair and throw that one out and put a new one in. And then on the storage side, it's an object store. So you're going to have an object store model. You're going to have storage pools that describe how those cards or containers are being aggregated and what's being used for each object store. So there's a lot of capacity information in there and as well. So we are actively working on this now. The work is visible right now to folks who are members of the TWIG. If anybody is interested in that, please let us know. Please feel free to join the TWIG, get access and help us. One of the things we're going to do here is in another couple of months, most likely time frame, we will be releasing a working draft. So it won't go out as a full, we won't publish it entirely. What we're going to do is basically put it out so that we can start getting that iteration and getting more companies involved in this to review the models, shred them, look at both our models and the mock-ups that we've developed. Okay, so how do you, switching gears completely, how do you get started if you want to build a swordfish system? There's actually I like to spend a little bit of time here just on tools, which I know is not necessarily everyone's favorite, but we have some really cool tools. So you can do everything from, I want to get started on building these. We have a mock-up creator. If you want to take a snapshot of a running system and just get the entire thing so you can tweak it and modify it, the mock-up creator, you just point it at it, phew, in a minute you got a whole snapshot that looks like that system. And then there's some other tools you can build on top of that with. So like the mock-up server, you just drop them in a mock-up server and then you can query that instead of querying the live system. Or if you want to create your own mock-ups, same thing. You can just drop them in and look at them. If you want to get more advanced, you can move to the Swordfish API emulator. And what this does is basically for every possible object source it basically instruments every single schema and gives you the ability to basically do the same thing, drop mock-ups in there and use a subset of them. But the other thing you can do is, this is a Python-based system. It supports all the CRUD. Get, post, patch, delete on every object, and then you can start going in and customizing it for your own implementation. One of the things you can actually do with this is turn it into your real system if Python is perfectly acceptable to you. And in a lot of domains, Python is perfectly acceptable. So this actually gives you something that is already compliant with all of our test tools and our validation tools, which I'll get to in just a sec, and gives you that starting point, right? It's implemented with every possible object. You go find the instance of the object that you care about and you modify that. And you give it its appropriate behavior. And I know this works because I did it. I actually built an NVMe service that runs on Linux, runs in user space, talks through NVMe CLI, and reports back information on every NVMe device attached to a system. And that's also available in open source and available to, if folks want to take and extend that and use that in your own NVMe environments. So all of these tools are, the little links are on the GitHub/SNIA, GitHub/DMTF. You'll find a ton of these. We also strongly encourage folks to validate as you go. So there's a lot of different tools out there that let you check. Number one, are my mockups correct? Or do I have any syntax errors? You can check that. And then when you get to a POC, you can start looking at or if you're creating a profile to say, this is the functionality that I want to advertise, we have tools for that. We have a use case checker, which right now on the Redfish side is got some basic stuff and also a bunch of, kind of system specific stuff. Those are things that can be extended as needed. And then we have the service validator and the interop validator and the protocol validator. And so those three tools basically check, one of them checks, do you have all of the required functions instrumented? Another one checks, are you returning the right HTTP return codes? And all of those are just, you can run against any implementation and get, say, oops, that one's, I got that 90% right, I got that 95% right, I have to go fix that. It helps you identify issues very quickly. The interop validator uses profiles to test the functionality you've implemented and basically say, does it match? OCP has profiles. We're working on getting some sort of storage-specific profiles there. SNIA has 25 of them, something like that. They're all tiny little things that you can go look at and say, again, the provisioning case I used earlier, does this actually, are you returning all of the right headers? And then if I run this command, does it actually return properly? So these are all largely in the conformance space. These are not compliance testing. These are all conformance, making sure your behavior is correct according to the two specs. So just a quick example of these, and I'm running well on time for a change. So one of the things we've done on the Swordfish side is we have a long history of doing conformance testing. We've had the SMIS conformance testing for years and years and years. So we've created an equivalent one on the Swordfish side where we bundle up everything and look at what the checks are and make sure it conforms to the base requirements that are in the Swordfish spec. And then from there, you can validate, again, it runs the service validator, runs protocol validator, runs interop validator, all for you. And then the interop validator, you can actually pick, what level of functionality, and it will walk you through, do you have it advertised in the features registry properly, and have you instrumented everything you needed to instrument? So, again, test early, test often. I didn't say vote early and often. I said test early and often. And so one of the things that we'll be eventually looking at adding is, a self-certification. But right now, we have everybody coming through SNIA to work with us on that. Just a really quick view of what this looks like. So for every run, you can see the results and in a nice, it brings up a, well, I won't say really pretty, but it brings up a consolidated view, and you get HTML results, plus you can dig down into much more detailed logs as well. And so this really gives you at a glance, how did you do? Oh, and you can see on this one, we failed 3 things out of 5. That's not great, but we passed 2 of them. So you can actually use this and then dig down into the details, like here. So if you're running the Redfish service tests, boy, this is so tiny. I can't give a specific example on here. But you can see in here it basically says everything is passing, a bunch of stuff is not tested, and the like. And then when we go to publish, if you want to publish your results in a vendor-neutral way, you can work with SNIA to do that. And we post them on our website, and you can then point customers to those. And the other thing we do here is we only post features that have officially passed. We don't say you failed at anything. So this is a negotiation. We can also work on ensuring that the data is posted and the results are posted out there when you want to see them posted. So if you want to put a 3-month embargo on, like everything passed, but we're not shipping for 3 months, so don't put it out there for 3 months. We support any of those kinds of permutations. We also have, with SNIS, we have committed to keeping all of the results online and available for up to 5 years after basically we've stopped accepting new submissions into the program. Consider these to be permanent for at least until at some point we would discontinue the program. We would also commit to having those out there for several years following that. Since those are targeting at clients and regulatory and others, that's a pretty important thing. They're here, they're staying here, you can always find them here. Troubleshooting from test results, this should be relatively obvious, right? Flag something red, and you'll get a descriptive message that points you to where it is as well. For individual features, again, we'll go back to, I don't know which one this is. It's really tiny. Each one will show pass-fail. And so if you say, like, I'll use the provisioning example, right? Do you have volumes instrumented? And do you have the right headers returned on your volumes? And if I actually post to a volume collection, does it actually come back with a volume? That's what you'll see here. So whatever is in that profile, and those profiles can be your profiles, they can be our profiles, they can be OCP's profiles. Any of those we can set up to run in this environment. So if you are interested in engaging more on any of this work, come to SNIA, join the twig. You can also join the community. The community focuses a little bit more on education, promotion, and helping to, identify feedback on, from the broader industry. We handle the alliances and some other work like that. If you want to join the twig, also on the community is the one that supports the lab and the CTV program. So talking about the storage management lab, we have we used to have a big tech center. With the pandemic, we actually migrated down to a colo, which is working really well for us. But we have systems that are in there and donated by a series of companies. This is an NDA environment. You can put equipment in here. You can put pre-release in. You can test against other people's stuff. And all of that under the NDA agreement you'll sign on that. But with the new SNIA membership model, it's free to join. So you can actually get in here and work with these systems without any additional expense. The conformance testing, we're still looking at we tweak the pricing on that. Conformance testing is a little bit different. But in terms of just getting access to the tools, getting access to other people's stuff, we also share the lab with the Redfish. There's a Redfish interoperability lab in the same facility that we host. And if you are looking, we can look at our plug fests. We do allow joint access to those as well, so you can see the Redfish and Swordfish systems. In general, we would require folks to get permission to access the DMTF ones outside of the plug fest, though. But they are also available, so if you're a member of DMTF, you can actually get in and do both. All right, I already talked about the Plug Fest. We've been having a Plug Fest this week. We had one back in April. These are our face-to-face Plug Fests. If folks are interested, we don't have the next one scheduled yet, but anybody interested can just reach out and let us know, and we'd be happy to work with you on, a small, if you want kind of a private session, we do those too. just trying to help people get up to speed and get going. And here's my eye chart. The one thing I will point off on here is really the where to find more info. Go to SNIA.org/swordfish. Every single link on the page is on there. So that's the only one you have to remember is SNIA.org/swordfish. And you can get to all of these. But there's a lot of information that we put together. We also reference all of the Redfish materials. We're partnering with the Open Fabrics Alliance on storage fabric reference design and reference implementation that they're working on. And then obviously NVMe Express as well. All right, we have about three minutes left. Any additional questions?
We've posted versions, checkpoint versions up to ISO 2 now.
Oh, yes, thank you. Yes, we have recently released the 128. 124A was the last one that went up, but 128 is in process of updating the Swordfish ISO standard. That usually takes 9 to 12 months to get through that process, and we started that a couple months ago. So we're expecting next summer we'll be able to announce that the ISO standard for Swordfish has been updated to the latest.
When you roll faster than they do.
Yes, Myron.
For the events, is that going to be the inbound NVMe events, or the out-of-band NVMe events, or both?
It's a mapping between. So some of the events we can look at basically what makes sense. So we want to customize, in this new model, we basically want to customize and say, what are the really important events? So we have things that basically say, there's a standard resource one that basically says, I created, I deleted, something like that, state changed. All of those can go out as just standard messages. But if there's some specific things like, I went into an invalid power state for, my NVMe device went into an invalid power state, that would be a really good example of something we'd want to turn into an NVMe specific event. So you may have a list of those, and love to get a list from you on what events we'd want to see. All right. Any other questions? All right, I did really good on time today. There's 1 minute left. 1 whole minute.